Welcome to episode 2 of Build Day TV. I'm Alastair Cooke, and we're continuing our look at AWS's virtual private cloud networking. Joining me for this journey is Jeffrey Powers. How are you doing today, Jeffrey?
I'm doing great. How are you doing, Alastair?
I'm really good. It's a bright sunny day here in Tauranga. While we're thinking about things we can do, we're still staying at home and we're still learning. So we're going to take a look today at firewalling on VPC. And we saw this illustration in the last episode when we looked at networking, and we saw the idea of having DMZs is common on premises. And I like to draw parallels between what we already understand on premises and what goes on in AWS, because usually this is the way we learn. We build knowledge upon piece upon piece. So one of the fundamental things on premises with firewalls is we have a limited number of firewalls. And these firewalls are usually licensed. We're paying usually either for the number of network ports on the firewall or the throughput of networking on the firewall, or possibly both of those. And so on premises, we tend to have a firewall that is a router, so it connects subnets together and controls traffic flows between them. But firewalls typically on premises don't control traffic within a subnet. So they are purely about being a router rather than being a switch. So they're a layer 3 device rather than a layer 2 device. And as a consequence, we will often have more subnets. And so we will have dedicated subnets for DMZs. And if we're in really secured environments, it's not uncommon to have multiple DMZs. We might have a DMZ dedicated to each application that needs to be able to be published out to the internet. And you do this so that if one of the applications is compromised, it can't be used to directly attack other applications. So that separation out is a really common design pattern. Of course, we often do want to provide security within subnets on premises. And in that case, we usually use the firewalls inside the operating systems where we have our servers. So it might be that we've got Windows servers using the Windows firewall, or we've got Linux machines using IP tables or some other control mechanism for the Linux firewall. Or we might install a third-party anti-malware product that includes firewalling. But we have firewalling capabilities inside operating systems. And this is actually true whether we're on premises or we're in AWS. But it is the way that on premises we get security within subnets most often. So it allows us to do some control and not necessarily trust everything that's on the same subnet with us. Now, the challenge with operating system-based firewalls is they're distributed firewalls. There's one inside each operating system, and usually distributed management. Now, sometimes we can do some policy-based management, but most often it's point by point inside each one. And then we have to wonder what happens if the operating system inside the machine, inside the virtual machine typically, gets compromised. Could the firewall be disabled inside that compromised instance? And that would then open up more ability to attack. And so operating system firewalls are great, but they're not necessarily the end tool of our problems. And this is why we've on premises retained physical firewalls and virtual machine-based firewalls, but segregation at the edges of subnets. So this is what we have on premises. What I want to talk about and focus on in this episode is on AWS. So Jeffrey, we looked at the software-defined network that we have with AWS. We looked at using VPCs with subnets and route tables last week, and that allowed us to control quite a lot of network flow.
Yeah.
And it's important to see those as places where we're setting a policy for the software-defined network. Right? It's not that we're actually separating out switches and having separate routers between them. But it's more that we're setting a policy for how the software-defined network works. And that SDN is going to do a check of those policies every time network traffic occurs. And those policies determine how the network traffic transfers rather than some physical switch somewhere. The intelligence is all in the software-defined network, and the SDN makes decisions about forwarding traffic. And it does that based on the policies. So the policies we saw in the last episode were about subnets and route tables.
Okay.
In this episode, we're going to focus on security groups and network access controllers. These are the things that look like firewalls, whereas subnets and route tables looks like physical infrastructure, routers and switches. So we built this last time. We built our own VPC, our own virtual private cloud, with its own IP address ranges. We created public subnet, we created a private subnet. What we're going to add in this section is the firewalls. So the security groups that wrap up EC2 instances and control traffic in and out of individual EC2 instances. And then the network access control lists that wrap up subnets. And these are two independent places where we can set policy for the SDN and control network flow. Okay. So we'll start with the security groups because the security groups are the most commonly deployed firewall on AWS. So a security group is a policy that's applied to an EC2 instance. We saw last week an EC2 instance is essentially a virtual machine, and it's got a network adapter. Well, actually, your EC2 instance can have multiple network adapters, and additional network adapters are called elastic network interfaces, or ENIs. And it's actually those that we apply the security policy to, security group to. One of the nice things about security groups is you can have multiple attached to an EC2 instance. So we have to have at least one security group in an EC2 instance, but we can have multiple EC2 instances having the same security group on them and multiple security groups on a single EC2 instance. And that's really a nice structure to be able to have, to be able to reuse the security groups across multiple instances. The default configuration for a security group is to allow no inbound connections. You must explicitly allow inbound connections on a security group, but that all outbound connections are allowed. So when I start up my EC2 instance and I have it go out and pull updates from the internet that allow outbound traffic on the security group is going to allow those updates to be collected from the internet, provided, of course, I've got the route tables and internet gateway and those kinds of things in place.
Okay.
But you can't create an EC2 instance without a security group. If you clickety through the wizard, then you get one created for you, but there must be at least one security group on the instance.
But it's as easy as just clicking through and setting it up, and then you can adjust it later.
Yes, so you absolutely can change security groups later. And one of the really cool things about security groups, and indeed NACLs, as soon as you make a change, the change is immediately effective. It's milliseconds from the change in the UI to the change in the software-defined network's behavior. So if you need to open up a network port on an EC2 instance, you add the entry into the security group and immediately you can test and you can see that traffic flowing. That's one of the things I really like. It's not like there's 3 stages to deploy each change.
Yeah.
It is instantaneous. With security groups, there is an implicit deny, and we must explicitly allow. But security groups do not have the ability to explicitly deny. So everything is denied unless explicitly allowed, but there is no ability to do a deny. And that means that in a security group, the ordering of rules is irrelevant. There is no ordering of rules. There is just a collection of allows. And really nicely on security groups, they are fully stateful. So if I allow HTTP through port 80, incoming HTTP connections come in, and then the return traffic is allowed by that same rule. So they are stateful rules that don't require us to open up the return path explicitly. It is implied that if the connection comes in on this port, the reply from that port is allowed as well. And so security groups are really quite cool. But really importantly, I want to come back to the idea that a security group is a policy. So it is a group of rules rather than a group of EC2 instances. And sometimes we think about EC2 instances as being members of a security group. They're not. They have a security group applied to them. It is a group of rules, and it is just a policy. One of the things we sometimes miss in how security groups work is that EC2 instances inside the same security group, so they have the same security group applied, can't necessarily talk to one another. This is how it's very different from on-premises firewalls, where you often will have a group of machines and say, this group here are affected by the same set of rules and often are allowed to talk to one another directly. With security groups, absolutely not. Having an EC2 instance in a security group that allows maybe a SSH connection from one subnet into the security group, it doesn't allow across that security group, doesn't allow traffic between objects in the same security group. The security group is applied to them and as a policy. One of the things we sometimes do have to do is allow east-west traffic between these EC2 instances that have the same security group applied. In that case, we might actually have the source of the traffic in the security group as the security group itself. Allow the EC2 instances that have the security group applied to talk to one another on a particular port. And so you will sometimes see a security group as the source for traffic on that security group. Final note on this page, multiple security groups attached to your EC2 instances. I like having security groups in my VPC that allow particular functions. So I might have a security group that allows my Bastion host, my EC2 instance at my first point of entry into the VPC for management, that allows my Bastion host to connect to all of my EC2 instances, maybe on SSH if they're Linux boxes. Separate from that, and that particular security group might be applied to all of the Linux instances in my VPC. But separate from that, I will have security groups that allow my application flow. And so I can have multiple security groups attached to a single EC2 instance. And because each of the security groups simply contains a series of allows, the net policy on that EC2 instance is the sum of all of those allows. And so if I've got an EC2 instance that allows application access plus SSH access through two security groups, well, they're applied to one EC2 instance. You can both SSH and application access. It's a really nice structure. It allows you to use a smaller number of security groups and apply them more broadly. As an example, the green section at the top is the default outbound security group. And most people don't actually change this. Most people leave outbound traffic as allowed from their EC2 instances to everywhere. But in a highly secured environment, you may restrict that. You may say that the security group only allows traffic to particular hosts outbound. But for most organizations, you allow all outbound connections. The default inbound, you'll notice there's no green in the inbound because the default inbound is to block everything. You must explicitly allow. So you can see in my inbound rules there, the top rule is HTTPS on port 443 is allowed from anywhere. That's the CIDR range of 0000/0 means anywhere. But I've also explicitly allowed an SSH traffic in here. I've allowed this particular group of EC2 instances to be managed by SSH from the machine whose IP address is exactly 202.27.184.3. So that's a remote management access. And then as another example of how these rules can work, the bottom line there allows HTTP access, port 80, from a particular security group. So that SG dash bunch of hex, that means it's a security group. So this is allowing HTTP access rather than HTTPS from the EC2 instances that are in a particular security group. This chaining together of security groups is a really powerful structure that we have with AWS. And we can use one security group as the source of traffic for another security group. This is particularly useful where we're using EC2 autoscaling. This is a service where AWS automatically creates and destroys EC2 instances according to our rules, so that we can scale out and scale back in the number of maybe web servers that we have for our application. Autoscaling is a really cool feature that allows us to just deploy the amount of resource we need for the workload we have now. But the consequence of autoscaling, and a lot of AWS structures that are around temporary resources, is that we don't necessarily know the identity of all of the servers in a particular tier. And we want all of the servers maybe in our web tier to have access to our database tier. Well, we can do this by the security groups. Part of the definition in autoscaling is to say which security groups to apply to the EC2 instances that are created. And so we can know that all of the web servers that are being created and destroyed by autoscaling will be in the web servers security group. So on the database servers, we can say just allow access from the web service security group on the database ports into the database server security group. This chaining together is really useful. And the chaining allows us to not need more subnets where we have dynamically appearing and disappearing EC2 instances. We could have the database servers and the web servers all living in the same subnet, but with firewalling within that subnet. That's a really important thing for security groups. They apply at the network adapter on the EC2 instance, and they will firewall between traffic that's on the same subnet. So with security groups, it's like we have a firewall on every port on our switch. Every network adapter that plugs into our software-defined switch gets its own firewall policy. So I like security groups. I think security groups are incredibly powerful. And of course, they're mandatory to configure when you're using EC2. And so we must always use security groups.
Yeah.
For most organizations, security groups are your usual level of security. But sometimes we work in more secure environments. We work in environments where a single policy layer of security is not sufficient, or where there's weird audit requirements, where the auditors say, well, the audit sheet says there must be security controls at the boundary of the subnet. Do you have security controls at the boundary of the subnet? So two drivers that lead us to using network access control lists, or NACLs. Sometimes it's because we need more security that we can implement with security groups. And sometimes it's because auditors have weird legacy restraints. So the second place we can do firewall kind of policies is with this network access control list, or NACL. NACLs are attached to subnets. Now this very obviously then means if we need different network access control lists, we need multiple subnets. This is one of the places that we can have a conflict between that wanting fewer and larger subnets and wanting more security. And so this is one of the reasons why you don't necessarily always deploy network access control lists. You need a driver for it. Network access control lists are then associated with subnets, and that's really useful where we start deploying across multiple availability zones, and we'll talk about that in the next module. When we're deploying these network access control lists, the default is wide open. So there is a network access control list on your VPC when you create it. And we'll see that on the next slide. It's absolutely wide open. But a network access control list is an ordered list of rules. There can be allows and denies. As you work through this ordered list of rules, the first rule that matches the network traffic you're trying to achieve is accepted. So you might have a very specific deny to block an attack vector, and then a more general allow below that to allow network traffic for your application. And then the last rule is always a deny all.
Okay.
We then also have a complication working with network access control lists. NACLs are not stateful. So if I allow HTTP traffic into my subnet, the return traffic is not allowed unless I explicitly allow it out as well. So here's the default network access control list on your VPC. You can see that both for inbound and outbound, there are two rules. There is a last resort rule, the one in red, that says all traffic is blocked. But the default network access control list has a 100 list rule in there as well, which is all traffic is allowed. So by default, all traffic is allowed through network access control lists. But you might change that to be more restrictive. And here's a very simple, very poor example of a network access control list. On this subnet, I've allowed incoming SSH traffic from a specific subnet. So if you remember the IP addressing that we used in our previous example for VPC, we had a public subnet where I could SSH into one of my hosts. Well, this rule allows from that subnet SSH into another subnet. So this would allow me to SSH from my public subnet down into my private subnet. This was attached to my private subnet. But you can see the rule 100 in the outbound is a very broad port range. The inbound is saying specifically port 22, no other port. But the outbound range has to be huge because the outbound connection could be on high ports. The actual ports allowed back out has to be much broader because that's the way TCP works. Mm-hmm. Because NACLs aren't stateless, you must explicitly allow this. If it was a security group, it would be allowed without any explicit listing of ranges. Consequences that network access control lists are more complicated to configure, but you absolutely can. As a result of having two places you can set firewall policy, we get a direct up question. Which should I use? Should I use a security group or a network access control list? And the answer is it's not an or, it's an and. You must use security groups. Can't create something on a VPC without a security group attached to it. But the network access control list, well, it's actually mandatory as well. It's just that the default is wide open. If If you want to add additional security, you can do that by restricting down the network access controllers. Create new network access controllers to attach it to the subnet that you want to be more restrictive on. And quite often what we see is that there will be a small part of the network that you want to be more secure. Often it's the DMZ. And so you may well set some much more restrictive network access controllers just on the DMZ subnet and have a much more open network access control list in use across your internal network. You're still using security groups everywhere. Using network access control lists everywhere will drive you to have more subnets because network access control lists only work at the boundary of a subnet. Consequently, you need more subnets for more control. So a summary around how firewalls work on VPC. AWS has a massive software-defined network, and we're really just giving policies to that software-defined networking and describing them as firewalls. Security group is the default firewall that must be configured for all EC2 instances, and it allows outbound traffic by default. You explicitly allow inbound traffic, but return traffic is implicitly allowed. Stateful firewall. Network access control lists are optional and they wrap up a subnet. The default is wide open and they are stateless, so you must both define the incoming connections and allow the outgoing connections as well. Stay with us because we're going to show this to you in an actual demonstration inside an AWS VPC in the next video. Jeffrey, what do you think of this networking and firewalling?
Pretty straightforward.
Yeah, and hopefully the principles are fairly simple, and then the devil's in the detail as you implement.
I have a feeling we'll once we start to get in there and start doing things, I think that's when I'll have some questions to ask, for sure.
Yeah, and that's very much why we do the hands-on component, because it's once you start applying things that it becomes very real.
Yeah.
All right, Jeffrey, well, I think we're done for this video. Let's close it out and then head on into the demo in the next video.
All right, well, yeah, that was AWS Networking, Episode 2. Well, this is 2A. Stick around. Go over to the second one. That would be 2B. All right, well, that is part 1 of the AWS Networking VPC Firewalls. We will get into the demonstration on the next video. So go ahead and subscribe so you can, and of course the bell notification so you know where those videos are. And follow the playlist and follow us. So thank you very much, Alastair, and we'll see you at the next video.
See ya.